Hey guys, welcome back to our little generator side project. So obviously this generator is going to be charging the DC battery bank in Surrender. So she's maintaining an RPM now. She's charging the 12 volt start battery, which is for this engine. She's charging 24 volt battery bank that we simulated. So now we're going to be starting on the exhaust system. So the exhaust system is going to be a water-cooled exhaust system to basically keep the temperatures low or lower in the engine room, and obviously within the case and all that sort of stuff. So I did a very quick drawing here, just for people who don't understand like water-cooled exhaust. Basically, you've got your cooling, a normal engine, you've got your cooling circuit within the block. But with this here is our exhaust. That's our exhaust routes, we're going to call it. So what would normally happen, that would go out, go through a silencer, go to atmosphere. But we're going to be cooling the manifold. So they'd be cooling the manifold. But what would normally happen is you'd use you'd pass through a heat exchanger, then you'd use the raw water, go through the manifold, and then it'd go back into the exhaust stream. But what we're going to be doing is we're going to be running antifreeze through the exhaust manifold. So this here is going to be our circuits. So it's going to go from the engine through the heat exchanger, out of the heat exchanger into another heat exchanger. So the heat exchanger is going to be, this is our hull. There's going to be an electric pump, so an electric raw water pump. So that's going to be pumping water into the heat exchanger, then back into the exhaust. So then that'll cool the residual heat, or it'll get the raw water out of the boats anyway. So yeah, today we're going to be concentrating on the exhaust, which is going to be a water-cooled exhaust. So let's go. So now we need to remove the existing manifold. Obviously this manifold goes in two into one. It's quite a nice shape. If it was motorsport, it'd be quite nice, but ours is going to be a bit more complicated around here, a bit less flow. But we're not going for like a maximum output engine. We're going for a nice, reliable, cool engine. So yeah, let's remove the exhaust. So there's a local brewery down the road which I always help them out. They're always like, the machine stopped, and so we always do them a lot of favours and stuff like that. But they do me favours as well. But in their cast-off pile, there's a load of fittings, like sort of very posh valves, and it's all 316 stainless. So I've had my eye on them for a while. So gone and grabbed them. So I think exhaust manifold. Here's the two cylinders coming in, it's going to merge into one. It's not the best flow, but as I said earlier, we're not going for a maximum output engine. So we're going to be putting sleeves inside the manifold. That'll keep the water inside the manifold and not come out the studs. So we need to do some modifications to these now. Basically, I need to cut these rings off all of them. And then we can start to line her up. Hopefully then put a few tacks on her, then we'll finalise the welding later. Okay, let's go and cut these off. So we've got our stainless elbows and our T here. So we've got some, at the moment, simulation like sleeve. So I can adjust it all in and out, and then we can weld this up, and then we can get it in, and then I might tack. Obviously I'm going to be using these ones here. These ones here are stainless, so I might tack it all up, slip it on and off, and then all we've got to do then is box it in then, haven't we? Cool, so it's all lined up. I've got a piece of aluminium, so you can keep flipping it over, you don't have to keep taking the clamp with you. Give it a quick heat. just to basically like get rid of any oil or anything like that. So for now, I'm just going to do weld in the middle. Give it a few tacks. Okay, so all the taper fittings are all tight, so give it all a good weld now. Should have got Gemma to do this. Okay, so we'll allow this to cool, then we'll give it a good sort of clean up and inspect. If you notice, did like a root run, and then allowed it to cool slightly, then we did a cap run. Maybe shouldn't be welding near this. How do I? Yeah, looks good. It welded quite nice. Okay, so I've had my lunch, allowed it to cool. Give it a quick flick over the wire wheel. It's not the prettiest of welding, but I wasn't going for pretty, I was going for like non-leaky. There's a few little areas like there which is a bit suspect, but so I'm going to grind them out and I'm going to refill them just because this is going to be encased, so it's quite awkward to test now. I mean, I could go, I can't even cap it right. So yeah, grind them out, weld them up, then we can forget about this then for now, and then we can continue with the rest of the build. So I'm making a pattern of the exhaust, of the original exhaust, how it goes onto the Kubota engine. So to basically do it, I used to always have to do this as a kid on the bikes. Whenever we used to rebuild the engines, you could never afford the gaskets, or it was wrong, or we took it off to modify the ports. And so you basically find something hard to hit against, or the casting you want to replicate. Use the ball of the hammer, and that basically finds the holes behind. So there you go, we've got a little template now of the exhaust stud pattern. So we've got a slight mock-up going on again here now. So I've made another template. All this has is the stud patterns in it. So now my other template now fits on nicely onto the end. So that means we're not deflecting the studs at all. So hopefully now I'm going to tap these on, which will give us a witness mark on where we want our holes to be for these sleeves to go through. So now we'll tap the actual pipe, then hopefully that'll give us a nice witness to where we want the holes drilled in the base in the back plates. Cool. Take it off and have a look. So you can see now where it's punched these out, and we can see like the rings here where the exhaust wants to go. So let's cut them out neatly and hopefully transfer that onto a piece of steel. Okay, so we've cut our back plate now. So now what we've got to do now is line it all up. I need to do a bit of fettling on these to help it slip in. and then we can probably screw it up to the actual engine, then we'll put a few tacks on her. Sort of mocked up now, got our steel face plate now. So now we need to make an end plate which then goes over just the one outlet now. So we'll make an end plate, going over these sleeves, and then going over this part of the exhaust here, and then we'll cut this back once it's welded. So I've just kind of figured out if I use the same template that I used on the fronts, then that'll keep all my dimensions the same, but only cuts the one hole out, because this tube here is technically coming straight through, isn't it? So, okay, so here's the internals of the manifold. We've obviously got to put a box around it soon, but I can start now welding this up. So yeah, get a few tacks on it now inside. We weld quite a bit inside, and then we weld outside, and then hopefully that will reverse the distortion. I've bent this one slightly, not knocking her on earlier, but we'll get a few tacks on her and then straighten her out before we box her. But yeah, quite impressed, looking good. Just cut up some box section now, about 4mm, so then we're going to cut it in half, and then we're going to make some like clams to go around the outsides. Right, so plan now is to slip them over there, doesn't fit. Okay, oh it does. So they're going to go over there now to say goodbye to all the lovely insides. Which, she's not very pretty, is she? But doesn't really matter. And I've left all the snags and all that sort of stuff all over it because we wanted it to like reject heat. So all the snags, increase the surface area. Well, that was a slight miscalculation, wasn't it? So I need to take I need to measure it, remove some material from here, and let it snug down. So you could buy like heat exchangers for these engines, but you'll want stupid money for them. The second clam is cut. It's not a bad fit considering there's so much going on there. So I've been working out the water path. So I think it's going to come in high up along here, which is going to come from just below the thermostat, and then it's going to exit around here and then down into the heat exchanger. So it'll flow through this way, but we'll have a look at that later. Right, I'm going to tack this up. Okay, so we'll mask up, weld her up, let her cool down again. The outer clams are welded on now, so I'm gonna just do a quick grind, make it pretty, not pretty, a bit smoother, and then we'll try and put some air into it somehow to try and pressurise it, to try and find any holes. Okay, so we need to now pump some air into the chamber now, so that'll show us exactly where it's leaking and stuff like that. So to do that, I'm going to be using a cylinder leakage tester, which I used to use on the race bikes. Supposed to do it after every race really, because you can prevent problems. Anyway, it finds leaks, or percentage of the leak anyway, but we can make sure it stays on zero. So we're going to be using a brake pipe end, so we're just going to weld one of them onto there, because that's the only thread I could find that fits my tester. So that's going to go onto there. We can have a blanket, or we can use it as like a steam pipe, like a bleed off. So yeah, that's the next job, weld that onto there. So we've set our cylinder leakage tester up, so we can basically increase the pressure on the regulator, and then it's showing the cylinder leakage, so it's showing that we've got a leak. And guess what, we can hear a leak. So there's a leak right here, which You see, like right there, there's a tiny little leak. So we'll grind this out, and then we'll retest. So we've got rid of all the leaks now. I've got a slight leak around my joint, but hey, doesn't matter. So yeah, that took a lot longer than expected. Currently we've got like 20 psi in it. I can probably pump it up quite a bit more. Let's get rid of that. So we can. The biggest problem was this surface here, because obviously I know that we need to make a mating surface to this silver head, but every time I ground it back I was revealing the cracks again, so I was trying to go deeper, and then it was causing me problems. So I've decided now to build up with weld the mating surface. So to get this mating surface flat, I'm planning on clamping it in the lathe, spinning the whole thing, and then we'll just sort of machine away at it. But to do that I need to weld me the exhaust stub, I'm going to call it, on, just to give me something to clamp to on the lathe. So that's the next job, I think. So we've got her clamped up in the lathe. I basically pushed that into there, locked her up, got her centered, put a tack on it there, turned out quite well. And then obviously we're never going to get it bang true, but basically I was measuring, and then from the actual face we've got 20 mil, and then if we wind it all the way out to the outside, so then we've got basically 20 mil there. So we should be able to get plus or minus a mil, but all we're bothered about is these two faces, aren't we? So if we weld this up now, then after lunch it'll cool. It's going to distort some more some way, isn't it? But then we'll start machining this, and then the lows, then we'll put some more weld in it and machine it some more. So, how's it going to turn? Really? Let's see what happens, eh? Okay, so now it's revealing all the low spots now. So if we now weld up the low spots, then we'll remachine it again. So it's now highlighting a few little pits and stuff like that. So we'll just drop a few tacks on it, we'll grind it off a little bit, and then we'll machine a bit more. So then our two mating surfaces now are nice and flat to each other anyway. So we'll take it out now, we'll clean all this up now around here. Before we install, we might give it another quick whiz, just to make sure she's flat, especially after we do some more welding around here, because we're going to be welding like our pipe fittings on. So may get some more distortion, but that's good enough for now. Just gives a datum. So I've just had the engine outside. I've just drained the water off. I've removed, there was like a bung in here. Couldn't find a fitting or even what size thread it was. It was some metric thread, not a clue. So basically drilled the centre out of it, welded this piece of tube on it, put some nails on it. Anyway, so found a hose now. So the hose fits that nicely, and now we're we're going to put now another fitting of the same description into this side here. So the water's going to come along here, feed this side, shoot the water over this side, then it'll hopefully circle back, and then it's going to come out here. Then it'll come down, go back into the circuit. Okay, so we've now drilled our hole, got our selected pipe. We're now going to draw around the pipe, and then we shall cut this off now at this angle, and then we'll worry about the length in a second. Okay, so now the two pipes are now welded on. We'll give them a good inspect, and then we need to let that cool now, and then might be worth giving it a paint, I don't know. Yeah. Okay, so she's all painted up now. Check her out. All painted up. I've plugged both hoses just to make a loop so we can pressurise her. So now we're going to put some air into her now, and then we can do like a final leak test before she goes on the engine. The only leaky bit is on my test valve. So yeah. But that comes out anyway, so the whole thing, amazingly, is at least airtight at 25 psi. So, cool. What we need to do now is we need to make some gaskets now, and then we can bolt her up, and then start the plumbing. So I ordered some copper plate off my favourite shop. I didn't order the right size. I wanted to do one full gasket. Anyway, we're going to make two small gaskets. So I've got an original gasket, so we're now just going to copy that and make a copper gasket. So the reason I'm using copper conducts heat amazingly, so trying to equalise temperatures throughout the head and the heat exchanger. So they're all marked out. I'm leaving these long here because I can still retain some mass in between the head and the exchanger. So I'm going to go and drill these out. So we made our copper gaskets. The hole is under drilled at the moment, so I think it was 22 millimeters. I've drilled about 20 mil, and because before the generator goes to the boat, it's going to be doing a head gasket. The only reason I'm going to do a head gasket is because my head gasket only arrived yesterday from after we rebuilt it, which was a couple of weeks back. So because we ordered it from China, you never know when it's going to arrive. Anyway, so the head's coming back off to change the gasket. So, but it's sealed at the moment. So yeah, they're on. Oh, no, that fits beautiful. So manifold's on, screwed up. We're now beginning to plumb it. So we've got our, I'm going to call it a nice pipe here. Probably going to put a T in here anyway, because we're going to fill from here, because this is a bit of an air trap. But anyway, so now water goes into the manifold, comes out of the manifold, and then back into the negative side of the water pump, and then it'll go back through the system. So that'll basically circulate until the thermostat opens, and the thermostat opens and it'll still bypass. Then it'll go up, down here, through my temporary radiator, but that will be a heat exchanger. So then that will then go back into the circuit, blah blah blah, keeping everything at a nice temperature. Not cold, a nice temperature. Okay, so we're going to put some water in it, and then I need to look at the exhaust to make a silencer, just so we can carry on running at the moment. So we're going to make a very, very temporary silencer. Then we'll take it outside, then we'll give it a nice long run, get it nice and hot. Just for now, direct the gases away, keep it quiet. Right, let's take her outside and start her up. Okay, so everything's connected back up and got water in her. Hey, a lot of people have been asking, what's the rubber glove for? Because basically at the moment it's not a pressurised system. This is off a spray gun, so we're just using this to fill, and as a reservoir at the moment. So without this, the water just goes on, because it shakes everywhere, it just blows everywhere. That's all the rubber gloves does. Let's see if she starts up and see if the exhaust moves, and then we might do some thermal imaging on it to see if we can see a nice heat path and stuff. Anyway, let's see a bit yabbering. Bit of heat. A bit of throttle. The exhaust is blowing a tiny bit on the joint, so we might have a look at that. Yeah, still sounds good. In fact, it sounds quieter. I need to fix the exhaust up. Okay, so I've put a screw in the exhaust. Start again, shall we? The exhaust is running cooler than the cylinder head. The cylinder head is at 71 degrees, that's actually what temperature the thermostat opens. The exhaust is at 59 degrees. So we wait for the temperature to build and the thermostat will open, and then we want to make sure they stay the same temperature, that the exhaust doesn't go higher. The actual exhaust temperature is only 80 degrees, so obviously that's going to be shroud, and then eventually it'll have water going into it. So now the thermostat has opened, the radiator starts to get hot. Exhaust is still at 60 degrees, and the cylinder head is still at 71. The exhaust is still running cooler than the cylinder head. So I'm not sure at what point the camera battery went flat, but it did. Anyway, we had a good run, did some thermal imaging. The cylinder head was running about 71 degrees, this was running about 60 something, but it kind of shows it's working. So I could put my hand on the exhaust now. It's been run for maybe half an hour at quite a high RPM, but obviously we've got no cooling on this radiator, so this radiator soaks up quite a bit of heat, but it was working very, very well. I could follow the heat path until the thermostat opened on my thermal imaging, and then the thermostat opened, then I could follow it again. The exhaust didn't change temperature when the thermostat opened, which I was slightly concerned about. I was kind of slightly concerned that it was going to favour the radiator rather than going through the exhaust, but it didn't. It was working really, really well. Yeah, absolutely bob on. Yeah, so run it back inside and then we'll see what's next on the to-do list. So here she is in all of her glory. Obviously it's just in like a zinc primer at the moment, but she works amazing. Yeah, so next time we'll be making a heat exchanger out of all these lovely bits of copper pipes and tubes, some 28mm copper, some 22mm copper, some reducing tees. I think you know where this is going, so yeah, thank you ever so much for watching. See you next time.